Try this. There we go. Alright, so starting with motion, were there any of the questions that you guys wanted us to go over from the motion packet? Position, velocity, acceleration. Anything from the FRQ? Anything that we didn't finish yesterday? I'm looking real quick. Alright guys, you got a late start. Let's go ahead and focus in. I know there are lots of things that can be distracting. In the motion packet, we didn't go over very much yesterday. We went over what you guys were asking for in a moment. Nothing else? We went over 3 and 5 and 7. Oh, Alan.
First FRQ.
Okay. Do you have a certain part?
It's all of it.
Okay. That's actually what period 6 asked for also, so that's a good thing for me to go over. So we're just going to go ahead and do the first FRQ, the whole shebang, make sure you guys are okay with reading, interpreting. If you've tried it and you've gotten it, cool, go work on your 2012 soon. Thanks. Yeah, I got it. And if you didn't try it, you're working through with it now. Try to at least read the questions before I start going through. And once again, if you are not with us or you've already done this or you don't need it, etc., you can work on 2000. Yeah, go ahead. And if you guys are like chilling at some point, if you already know a part and you're waiting for another part, you can already be looking for what questions to ask on section B. We might go back to section A if it's something that you guys need, but remember our focus today is to go over any questions you know of from section B, which is graphing calculator, which you might want to get out of your graphing calculator. Okay, free response number 1 is a non-calculator, and question guys, what do they give us a graph of at the very, very beginning? Got to interpret what we're given. Velocity. AKA the graph of the derivative of the position, true? Mm-hmm. Moving on a line over the time interval 0 to 8, and they also tell us an initial position. Okay. When the object is at rest, that's a clue word, right, cool kids? You should key in on that. What is going on if the object is at rest? It's stopped, so velocity is 0. So we can say, when is v of t, show your thinking. At rest should attach itself in your mind to velocity is 0. Now say, oh, what do I have about velocity? A graph. And at what part of the graph will velocity be 0? Yeah, this is y equals v of t, right? So when the y value is 0, which looks to be the best we can do, when? T equals what? 5. And there's also another time at 8. They say the closed interval from 0 to 8, so we are allowed to use 8 as well. And if they give us units, we should always put it, oh, seriously, they didn't give you units? That's lame. Okay. The AP should always give you units, so you would put at this point, seconds, minutes, hours, whatever it is, right? If you want to box it, that's totally fine. If you don't want to box it, that's okay as well, as long as you make it clear. Clear, clear, clear. At t equals 5 and 8 because velocity is 0. Letter B. Evaluate the integral from 1 to 6 of velocity. Kiddos, how do I think about velocity, how do I think about an integral if I can't use fundamental units? Area under the curve. Because I have velocity up above, so then I need to find the area from t equals 1 to 6. You don't necessarily have to write this. Sorry, I'm just interpreting for you guys. So we're going to go ahead and go up to the graph and say, how can they expect us to find this area? Okay, what do we have? Yep, geometric shapes. If you want to use rectangles and triangles, if you would rather, you could use trapezoids, and that might make things a little bit easier. We have some options here. But, no, go ahead, Bridget, what'd you say?
Can you do a trapezoid from 1 to 5? Or do you have to do 1 to 4?
You could do a trapezoid, let's see. You could actually do it from 0
to 5?
to 5. Because you would have 1/2 height times base 1 times base 2. That would get you the trapezoid right there.
So you could do that in less shapes?
And then you'd have the triangle on top, and then down below, I would probably still just use triangles and rectangles on this one. I don't know, it's easier in my head, at least. So then when we go ahead and do, remember area above is positive, area below is negative. So with this triangle, I have a base of 1, 2, and 3, and a height of 1, right? Base of 3 and a height of 1, that would be 3/2, because 1/2 base times height. For the trapezoid, I have 1/2 of, if you turn it on n, that would be the base of 1. Height 1 plus height 2 would be 1, 2, 3, and 4, and then 5. So 4 plus 5 is 9, 9 times 1 is 9, and 9 divided by 2, 9/2. We have that, those are both positive. And then down below, we have a base of 1 and a height of 1 and 2. Yeah, those tick marks were just, I
Is it
apologize.
from 1 to?
Oh, did I not look at my actual bounds? I did look at my actual bounds, good catch, kid. So let's ignore all of that. There we go. So I just need to find that one. So I have a base of 1 and a height of 2, cut in half. 2 times 1 is 2, 2 times a half is just 1, but it's a negative, right? So I'm going to go ahead and put down here, area is equal to 3/2 plus 9/2, those are both positive, minus 1. Totally sufficient.
Wait, isn't the 9 halves from 0 to 5? It's supposed to be 1, right?
Oh, you were totally catching me on everything, yeah. Nicely done. What happens when I don't look at the question?
Happy birthday!
Thank you.
Okay.
Oh, so it's, oh, because it's 1 to 6, not 0. I see.
There we go. Yeah. I was just going between the entire interval. Danger, Will Robinson. So therefore, we don't have 9/2, right? That's the only thing that changes? Because the 3/2 is still the same. So instead we have a trapezoid with 1 and then 3 and 4. 1 and 2 and 3 and 4. So 3 plus 4 is 7. 7 divided by 2 would just change that. So then we end up with, here we go, 7/2 instead. So then we have 3/2 plus 7/2 minus 1. That's the danger about zooming in and zooming out and not being able to. So 7/2 plus 3/2 minus 1. Technically that is pretty quick to do because you have 10/2, which is 5, and 5 minus 1 is 4. So we could go ahead and write that. You could, of course, stick it to the man and not do a silly math mistake. But they do ask us for the interpretation of that meaning. We don't need to look at the graph for that. We just need to look at the formula. Kiddos, do you recognize the integral of velocity from 1 to 6? Yeah. We could say it's the displacement. I guess we could say it represents displacement of the particle. Say an object, okay, of the object. Between t equals 1 and t equals 6. There's different ways of saying it, but they didn't really give us a lot of context in this one, so we'll just say displacement between t equals 1 and 6 and leave it at that. Don't give us units, it would be in meters or feet or miles, whatever the distance label unit is. What is the position of the object at t equals 5? Letter B is what's going on over the interval 1 to 6, how much the object is displaced. But letter C says at, how should my thinking change? Integration is that change. So we can say the position at 5, kiddos help me out, I was doing it yesterday a lot. How does integration is that change work? Good, we have to start somewhere. X of, why do we have to start at 0? We have no option. Because they give us the initial position. We have to have a starting value. We have to have a starting value. Right?
Can I grab my pocket?
Oh, you don't have it yet.
How did you know it was oh, never mind, I get it. I was thinking of not net change, I was thinking of something else.
Okay. Does that make sense?
Yeah.
Okay. So we can say x of 0, but the dilemma is, kiddos, what are we going to have to add in order to figure out the change in between 0 and 5?
The area from 0 to 1.
You have to go from 0 to 5. The dilemma is, what did they ask for in letter B?
1 to 6.
So can we just steal the 4?
No.
Sadly, no. Now, usually on the AP, they don't make you remake the wheel. one question will morph or will be used in the next. In a case like this, but sadly in this one, I need 0 to 5 in order to find this correctly. So therefore, we could go ahead and then do, I guess we could go from 1 if we started at 0 and then found the integral from 0 to 1 and then got it to 1. But still it'd be awkward because the above in letter B is 1 to 6, this is 0 to 5. Anyway, so the initial position is 5. The integral from 0 to 5, okay, going on back up. We have a little 1 by 1 here, right? So that's going to be an area of 1. So we're going to have 1 plus 7 halves plus 3 halves, and that's it. Because it just stops at 5, so we don't have to worry about the rest. So we'll have 5 plus, and then we have that 1 plus 3 halves plus 7 halves. And once again, it would be measured in miles, feet, meters, whatever the position unit is in the problem at hand. I'm just not putting it, so you can say it. Yep, we can say it to the man. And I would have done it in letter B. It was, I don't know, my mind's like, ooh, it's a nice number, right? Maybe I should, for your guys' sake, just leave it at that and say, yeah, done. Okay, letter D, forever card. Absolute value. We have velocity. People in the back, just make sure that talking is productive. Make sure that talking is productive. If it's not, then just. How do I do absolute value if I have a graph and we're doing areas under because we know that they're geometric shapes, but 0 to 8, okay, I know 0 to 5, actually I know 0 to 6. I can keep going to 8, but what's going to change?
You have to split it up.
Yeah, I need to split it up in a sense that I can keep the 1 plus 7 halves plus 3 halves, right? But instead of doing minus 1 from 5 to 6, what am I going to do instead? Plus 1. Because absolute value is going to make whatever below above. So the absolute value function, if you want to think about it, is going to be the same thing as this, but instead it's going to be translated up. I think it goes down too, so it's even going to be translated up. And then back down. You don't have to draw that, you don't have to show that, just have the math show that, in the sense that instead of putting a minus 1 like we would do, we're just going to put a plus 1 instead. Instead of putting a, let's see, that's going to be a base of 1 and a height of 2. Instead of putting a minus 2, we're going to go to plus 2. And if you guys notice the symmetry, that's going to be 1 as well. So we can do plus 1, plus 2, plus 1. Once again, it'll be measured in miles, feet, meters, whatever the measurement, the unit of position is in this case. Last but not least, letter E, forever card. Speed increasing or decreasing. That's what speeding up, slowing down means. What forever card? What does the forever card say? Speed increasing or decreasing? Signs of acceleration and velocity. Now, the nice thing is they tell me a time to zoom in on, right? Don't they tell me at 2? So what I need to think about right now is I need to know what velocity is at 2, positive or negative. And I need to know what acceleration is at 2, positive or negative. I need to know what acceleration is. I need to know what velocity is. So looking up at the top, velocity, didn't we say that y equals v of t is my graph?
Yeah.
Okay, so then look at the y value at 2.
Positive.
Good. As I go at 2 and as I map up, that's going to be some sort of positive y value, right? So v of 2 is going to, just to be super clear, v of 2 is going to be a positive y value. How do I visually on the graph think about acceleration?
The slope.
Good. Acceleration is v prime. V prime is the slope of v. Or another way of thinking about it, Andrew, is this what you were saying? It's also whether v is increasing or decreasing at that point. The two coincide. The positive or negative slope is the same, or will be seen by if v is going up or v is going down. So at 2, is v going up or going down?
Up.
V is going up because the slope at that point is positive. So we can therefore say v of 2 is positive, acceleration at 2 is positive, therefore I am going to say yes. Since velocity and acceleration have the same sign, yes, they're both positive, but specifically since they have the same sign, the object is, what's my conclusion? Good. Speeding up. Or you could say speed is increasing. They're not gonna judge you on that. You're answering the same question. Is that good? All right, kiddos, we went through FRQ number 1, period 6 is also going to appreciate that. For sake of time, let's go ahead and transition over to 2012. Transition over to 2012. You guys yesterday were very much at the beginning of the packet. Period 6 was very much all over the packet as far as section A multiple choice. Frankly, they got further than you, so they got questions at the end. I saved their notes, I'm saving their notes online, because they're usually getting through more than you guys. I'm keeping your guys' video because I get to save it early in the day, and that's nice. But I am saving my work, because they're getting through more problems than you, in the sense that they got some hard ones at the end, like in the 20s, et cetera, that you guys just didn't get to. I'll probably get to them today, because there were, I think, 2 at the end that I didn't get to in period 6. So for right now, we're gonna transition to section B. Katrina, go with that.
My packet's missing page 17 into number 24.
Just randomly, I do have random extra pages. Sometimes the people that are stapling kind of have them all and kind of don't, so they give me extra pages.
I'll get you more. I need to put my notes.
Let me just give you all the extras and let's see if you can find a page 7. If not, I can copy it. Alright, kiddos, any from section B?
Yeah. Oh, this is 17 too.
Yeah.
Yeah, this is it too.
Okay, Katrina has, everyone's listening?
Yeah.
Just one number.
Okay. So it goes from 16 to 18?
Yeah.
Alright, let me just show it to you guys. Take a picture of it real quick. Or it's in the video, you can just look on YouTube and then pause it, or it's in my packet online, it's really cheap. So most of when they were copying, they just skipped over that page. Yeah. If you guys are doing things like trying to see how well you can do and what you can't right or wrong, like you'll want the question. No, I won't. Just to be honest. How would we do number 24, just because it's not in there? Corey, Caroline. Number 24, how do we do it? This is the page everyone's missing, we may as well go over it, right? We might not have time. Yeah, find it, the first derivative, plug in what? 2/3, and then set it equal to?
Set it equal to what?
0, because it's a critical number. AKA, if we take G prime, we're going to use the product rule, right, everybody? So if we do, second D first, plus first D second. How do I take the derivative of e to the d? Good. So e to the kx, what's the derivative of kx? Okay, good, because k is a constant. So just, if you guys need to, if it's ever a constant, just put a constant in. Derivative of e to the 3x is e to the 3x times 3, right? So times k. And see, in this problem, critical points can happen when the derivative equals 0 or does not exist, but this will never not exist. There's no denominator, no square root, no ln. So that's why, Bridget, I say set it equal to 0. Except they also gave us 2/3, so you would plug in 2/3, do some careful math. Hopefully you guys should be able to, one of the answers is there is no such one. That stinks. Alright, then maybe she'll fit this real fast. I'm pulling out an e to the kx because it's shared. Is that okay? I'm also pulling out an x because it's shared. I have left a 2 plus a k times, and my x is 2/3. Here's what a lot of people, kids, I don't know, get confused. Whenever you have factors equal to 0, how do you solve? Set each one equal to 0. But first of all, can 2/3 ever be 0? No. Can an exponential, think of your basic graph, can an exponential function with no translation ever hit 0?
No.
No. So you never have to worry about e to the. You would take ln of both sides, ln of 0 doesn't exist, e to the will never be 0. It could be 1 or 2 or 3, but not 0. So then all you have to worry about is just the 2 plus 2/3 k. So is there a k? Yes. How would you find it? Solve. So 2/3 k equals -2. Multiply both sides by the reciprocal. Multiply both sides by the reciprocal, if I can actually write a 2. And we end up with negative. Thanks for pointing that out, kiddos. Thanks for pointing that out. All right, section B though. Do we have questions? Okay. I'm just looking, a few others are looking.
$78.
78. As you guys are looking, I'm going to go ahead and get 78 in my calculator. The point is you need to be able to use your calculator well. Not that every question needs it. On almost any AP packet, any AP course syllabus that's been released, any AP test, it actually says you need to be able to do the following things in your calculator. Graph, find the zeros, intersections, maximums, minimums, be able to calculate a derivative at a point, and be able to find an integral over an interval. That's pretty much all you need to be able to use your calculator for. Nothing crazy, nothing mystical, nothing magical. Even though it might feel like it sometimes. Okay, so, what do we got? E to the tan x?
Yeah.
And then what's next? -2? Ooh! What is the slope? Anyway, hold on. First of all, crosses the x-axis. Can't we do a graphy thing from, I'm going to do Zoom Standard because it's all messed up from some other thing. Then kiddos, as soon as you have Zoom Standard, you can hit on. You can break it if you know you want to change it. If you hit on, it breaks it, it stops it graphing. You can go to your window and use the interval that they give you, which is just 0 to 1. That's all you're looking at. Where's my 0? There he is. So I can go ahead and go find my 0, second trace, and then use the 0 function. I can go a little bit before. I think I already am before. A little bit after. Oh my goodness, come on. I have 0.606. Why is A not right?
Because that's 0.
It says, what is the slope? AKA, it wants basically, no, not using that marker, dy dx at x equals, why am I going to put A? I'm going to put A equals 0.606 dot dot dot. What am I going to do to this number? Stow it, but how?
Second mode.
Quit, right away, second mode.
Stow.
Hit stow as soon as my screen stops freaking out. Stow.
And
You can make it A unless you want to keep Avogadro's number, make it B or C or something that you'll remember. Now, we need to be able to use our calculator to take a derivative. How do we take a derivative in our calculator?
math.
Math and go down to n derive or alpha, I think it's Zoom. Nope, alpha window. You can hit n derive pretty quickly there. Number 3, you can also hit function integrate there pretty quickly. D dx of, didn't you already put it in your y1, guys?
Yeah, alpha.
So you can go alpha trace, right? y1? Such that x equals?
A.
A. You got it. Dun 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 dun.
Dun, dun.
The answer is 2.961.
Question.
Not too bad, we just have to be able to use our calculators and notice when they're asking for it. Katrina,
Why did you use 0.606?
because it said, what is the slope at the point when the graph crosses the x-axis? So I found the 0, I found the position of the 0, and found the derivative there. Does that make sense?
Yeah.
So it was all to do with what they were asking. Yeah. Okay, hold on. You want to hit the stow button, but you have to make sure, like right now, Violet, if I tried to leave and hit stow, it wouldn't know what to stow. So I need to make sure that I find what I want first, like officially find it, And so I went like my 0 a little bit before, my 0 a little bit after. Okay, as soon as you get what you want and it's showing on the screen, don't hit any other buttons besides second mode. Get out of there, and it doesn't matter what's here. Hit the stow, and wherever you put it is where it's gonna go.
Okay.
Is that cool? So it's kind of like when you go from the graph, having found something, straight back to the home screen, it's storing that for you for a moment. But as soon as you type something in, it's gone. Or as soon as you hit a button on the graph, it's gone. Okay. Going back to B. Any other B questions? Yeah, Lauren. 81? Okay. Ooh. Water pumped into a tank. Isn't that like FRQ number 1? Probably not.
And I still put it
Alright, let me give you guys a second, just in case you haven't read this question yet. Water is pumped into a tank at a rate. Guys, they can talk about gravel, they can talk about water, they can talk about snow, they can talk about tea and biscuits, they can talk about whatever they want to talk about. When you see rate, you think that's some sort of derivative of a quantity, right? Gallons per minute, ooh, there it is. T is the number of minutes since the pump was turned on. Ooh, the tank contained 800 gallons to start with. How much water is in the tank after? I know it says after 20 minutes, but question, is this how did the level of water in a tank change in 20 minutes? Or is this what is the level of water in the tank at 20 minutes? Yeah.
What is?
Yeah, this is an at question. Not just what happened over, but what's the current status. What formula is that?
Net change.
Net change. Net change gives us an at. Uses an integral, but gives us an at. So if I were you, I would use something like W of, water at, okay? So I can say, what is the water level at 20 minutes? They don't give you a variable, so you make up one. Okay. So W is the level of water at a certain time. So W of 20 equals, how do I do integration as net change? I have to start from somewhere. What did they tell me? They gave me rate, and I'm going to plug that into an integral, but they already gave me, or they also gave me what the water level was at 0. Does that make sense? The initial amount when the pump was turned on, looking at my how T is defined, that'd be when T was 0. Plus, now I have an A and B, don't I? What's my A? 0. What's my B?
It's 0. Oh, what?
Because I know the initial, I know it was 800 at the beginning when the pump was turned on. And I know the 20, and what can I plug in my integral? A rate. Plug and chug it to your calculator, kids, because W of 0 was 800 gallons. Kiddos, tomorrow we're not going to start with motion. We're going to start with B, get a little further, but I'm also going to ask questions on FRQs. Monday we can do a couple more. I'm not going to spend a lot of time Monday on specific questions. Bye, guys. Any bonus AP review stuff you guys want to turn in is Monday. You guys good? Bye, guys. Get to meet online. Back tomorrow with questions. I want to answer. No. You guys are ready?
Wait, you're gonna give me a practice on what?
Okay, yeah. Send me a screenshot of something.
A lot of people.
Once again, period 6 might get further. I'll save their notes online so I'll check it out.